Hi everybody, welcome back to my Excel tutorial. Today we'll be talking about functions or commands in Excel for the normal distribution and the t-distribution. I'm not going to discuss those distributions. I think there are a lot of videos out there that do a really good job, so I will focus only on the Excel part of it. So, for each distribution, we have two functions that are kind of the two sides of the same coin. So, for the normal distribution, I have this normal S distribution, that is normal standard distribution, and this command is telling me the probability for the input, and that input is going to be the critical value or the statistic, or the value of the statistic. So, and that's going to be this black herring here. So you plug the statistic or the critical value, and it's going to give you the probability of being less than that number. For the inverse, that is the norm as inverse, normal standard distribution inverse, you're going to plug the probability and it's going to give you the critical value. So it's the other way around. Similar thing with the t-distribution, where t-distribution is going to tell you the probability, in this case to the right, it's going to be a right tail, and TINV, that is the t-distribution inverse, is going to tell you the critical value for a certain probability. So to summarize, the input for the guys with inverse are going to be probabilities, and for the guys with just the distribution, the inputs are going to be critical values. For the ones with the inverse, the output is going to be the critical value, and for the ones with the critical value as an input, that is normal standard distribution and t-distribution, the output is going to be the probability. So let me just show you briefly what is that I'm talking about. So if I go in here and I'm gonna try this number that is very well known, 1.96, and I tell Excel, please give me the normal standard distribution of this number. It's gonna give me the area to the left of that number, so since it is positive, it's going to be something bigger than 0.5, and in fact it's going to be something really close to 1, that is this number. And if I want to take this and get the critical value, well, the only thing I have to do is Excel give me the inverse of that norm standard deviation inverse, and select the probability, and it's going to give you the same number you use as an input at the beginning. Now let's do the same thing with the t-distribution. So Excel, let's get the t-distribution for this one number. I'm gonna say that the degrees of freedom is kind of a large number, 300. That will make the normal distribution and the t-distribution very similar. If you have a big sample or a lot of degrees of freedom, these two guys are going to be very similar. And I'm going to select a one tail because I don't want to be dealing with two tails for this case. I get this number that if I add it to this guy over here, and remember this is the right side, is going to be something really close to 1. Now I want to get the inverse of that, but in this case, as described in here, this is 2 tail. So one thing I have to do is I have to multiply this by 2, because by default Excel is going to divide this thing in 2. So I'm going to multiply by 2, and then I'm going to select the degrees of freedom. I'm going to say that that is 300 again, and there you go, I get the same number all over again. So let me do a brief example of this. Let's say that you were reading the papers and you find that somebody found that the average height of man is 75 inches, but you don't think that is true. So you go ahead and collect a sample, and you get this sample mean that is going to be your point estimate for a sample of 200 men. You calculate the standard deviation of that sample of yours, and you got a 5, and for some weird reason you know the population standard deviation, and that is 6. So if you don't know the population standard deviation, you're going to use a t-distribution. But if you know the population standard deviation, that is not going to be very common, you will use a normal distribution. And that's going to be the only two differences between these two cases. So the first thing is to calculate your statistic. And the way to do that is using those formulas in here. So the thing you have to do is just from your point estimate, subtract the claim you're trying to prove, that in this case is going to be that the mean equals that the mean equals 75, and then divided by the standard deviation divided by the square root of the population. Same thing over here, the only difference is that you use the sample standard deviation in this case. So this is going to be your statistic, that is your point estimate minus the sample minus the whatever claim you are proving, then divided by the sample standard deviation in the case of the t-distribution, divided by the size of the sample, the square root of that, that is the same of taking something to the power of 1/2. That is going to give you the statistic. Now you need the probability for that statistic. So since this is a two-tail, one thing I need to do is I have to move this to its equivalent on the positive side. Why? Because otherwise this is going to give me the right tail, and that is going to be something really big over 0.5, and that's not what I'm looking for. I'm looking for the numbers on each, the two values of the statistic that are going to be comparable to the critical values of the rejection area. So I'm going to do this guy multiply by -1, that is the same as negative, this cell, and the degrees of freedom is going to be my sample minus 1 degree of freedom that I lose out of calculating the standard deviation. And I'm going to do a one tail because I don't want to get complicated with the two tails. It's just going to be confusing in this case. So I get this probability, and this is really small. This is clearly less than 5%. So this guy is going to be clearly in the rejection area. And that I can prove that by looking at the lower critical value and the upper critical value. And the way to do that is just take the function for the inverse and plug your alpha over 2, that in this case is going to be 0.25, and then use your degrees of freedom. And this, if you multiply this by -1, is going to give you the lower critical value. And just multiplying this cell by -1, since this distribution is symmetric, is going to give you the upper critical value. Since your statistic is below the lower critical value, you're going to be here in the rejection area. In the rejection area. With the normal distribution, the only thing that changes is that now you're going to use the population standard deviation. That is this purple cell in here. The way you calculate the test statistic is going to be pretty much the same as we did with the t statistic. The probability for that is going to come out of using this normal S distribution over the statistic that you just calculated. And this number is going to be very small, clearly less than 5%. And that is going to tell me that I'm going to be in the rejection area, somewhere around here. The same conclusion I can get out of comparing this statistic to these two critical values that are going to be the lower bound and the upper bound of this sort of interval that we have in here, that is gonna define the non-rejection area. So since your number is out of this area in here, you're gonna be in the rejection area, and in fact you're gonna be to the left. Then you're going to reject the null hypothesis, same as you will have done if you only look at the probability. So that's it for today. I hope it was helpful. If you like it, please give it a like. Thank you so much.